Hi everyone, welcome to the video lesson for Thursday, March 18th and Friday, March 19th. Today in class we continued working on double replacement reactions and predicting the results. We spent almost all of class today working on a few practice problems. Some of you towards the end of class did start your double replacement lab. Remember, this has been assigned to you on Canvas. You get 2 attempts. And I strongly encourage you work on those practice problems, or at least use those practice problem worksheet to help you organize your thoughts and your ideas as you're going through that lab. It'll really help you out, and use that lab to help you answer the lab questions. Okay, that sounds a little bit weird, but remember, you've got 8 different reactions, and each of those reactions is repeated on the bottom half of your lab. You get asked those 8 different reactions. Then the second half of your lab are videos of those reactions. So if you said there was a reaction, but then the video shows there's no reaction, you might need to change that answer. Or vice versa, if you say that there's no reaction and the video shows that there is a reaction, please use that hint to change your answer so you get the best possible score. So let's dive into our warm-up. So your warm-up on Canvas looks a little bit different than it does here in my flip chart. I had to structure it a little bit differently, so I actually broke it down into 5 different questions. First, I asked you, what are the 4 different ions we have to work with? The second question was, what are the 2 balanced formulas for my 2 reactants? Third, I asked you, what are the 2 potential products of this reaction? Fourth, I asked what are their states, so solid, aqueous, or gas. And then finally, I asked you whether or not a reaction actually took place. So to answer number 1, you need to pull out your periodic table and common ion chart. Whenever you're looking for an element, remember I always say you should start over here with groups 1 and 2. That's where we get most of our elements from for our questions for you. If it's not here, then go to the right side of the table. If it's not over here on the right side, then look in the middle. This is a great way so you're not just scanning the entire periodic table looking for your answer. So first we have potassium. So I'm going to start looking over here. And there it is. Potassium is K. It's in the first group, and everyone in the first group has a +1 charge. Next, I need to find phosphate. Now look, it ends with an ATE. Anything that ends with ATE or ITE is after the periodic table on our common ion chart. And neat little trick, it's on the right side of my formula. It's on the right side of the chart. So if I look down here, I will eventually find it. Phosphate is PO4 with a -3 charge. Next up, I've got barium. So I'm going to start looking over here again. And there it is. Ba is my barium. It's in group 2, so it has a +2 charge. And then I have bromide. I have a saying, if it ends with "ide," that means it don't hide. So bromide is going to be somewhere on the front of my periodic table. It's on the right side of the formula, it's on the right side of the name, so it's on the right side of the table over here with all these negative ions. So remember, when my nonmetals become ions, they change their ending to "ide." Chlorine becomes chloride, sulfur becomes sulfide, bromine becomes bromide. Oh, there we are. Bromine is bromide. So it's in group 17, so it has a -1 charge. That was the answer to number 1 in your warm-up. Number 2, we need to know what are the balanced formulas for my reactants. So I need to do the crisscross rule. So let me copy my potassium. And my phosphate. So I'm going to do my crisscross rule. The 1 from my potassium comes down. That's how many phosphates I need is 1. I don't need to write a 1 subscript. And I don't need to write a subscript of 1. The 3 from my charge on phosphate comes down to my potassium. It doesn't matter that it's a -3. We can ignore the positive and negative of the charge when I'm doing my crisscross rule. All that matters is the amount. So I only need 1 phosphate and 3 potassiums. Next up, barium bromide. So let me copy my barium. Let me copy my bromide. So I do my crisscross rule again. The 2 from my barium becomes the subscript on my bromide, and the 1 from my bromide will become the subscript on my barium. So I only need 1 barium, but I will need 2 bromides. That is our answer to question number 2 of the warm-up. Now number 3 is, what are our potential products from this reaction? Well, the strategy that I have given you is, let's take the first ions from my reactants and write those ones in first. So my first reactant started with potassium. So I'm going to make my first product start with potassium. Then my second reactant started with barium. So I'm going to make my second reactant begin with barium. So I've got the same starting ions. And the reason why I had you list all the possible ions is that we kind of have a word bank here, or an ion bank to pull from. I know I need to use all 4, and I've so far used 2 of them. So I'm done with my potassium, and I am done with my barium. Now I need to place my anions. So let me make a copy of my phosphate. So I have 2 ions left and 2 places where I can put them. Remember, I always have positive and negatives in my ionic compounds. Always a positive ion followed by a negative ion. So there's 2 places where I can put phosphate, here or here. Well, I can't put it here with potassium because I'm switching dance partners. It started with potassium over here. So I can't put it with the same dance partner. So even though I said there's 2 different spaces, there's only one correct answer. My phosphate has to go with my barium. So now I've used up my phosphate. The only thing I have left is my bromide. So let me copy my bromide. Now, I couldn't put it with my barium to begin with, but now I also can't put it there because there's no space. There's only one space left where it can go, with my potassium. So now I need to do my crisscross rule to balance the charges. My 1 from potassium goes down to my bromide. The 1 from my bromide goes down to my potassium. So I don't need any subscripts here. I just have 1 of each. And then my 2 from my barium goes down to my phosphate, and the 3 from my phosphate goes down onto my barium. So I have Ba3. Now, be careful, phosphate is a polyatomic ion, so I need to put parentheses around it, and then I'll put the 2 on the outside of those parentheses. So let me put that down. Make that big, and make that deleted. So this is my answer to number 3. Here are my potential products to my reaction. Now for question number 4, you need your solubility table. This is on page 4, 9, and 10 of your guided notes. Page 4 is really good because it goes a little bit more in depth with that key to tell you what the different symbols mean. Okay, so let's look at my potassium and bromide. So here's my blue for potassium. and green for my bromide. Where I meet, I get an S. Now, a lot of students think S means solid. Now, when I write my states, yes, S does mean solid. But on this table, S stands for soluble. If something is soluble, it means it dissolves in water. All of these reactions are taking place in water. So if you get an S, pop, pop, then your state of matter is aqueous. Next, let's look up our barium phosphate. So I'm going to go down, find my barium, highlight that row. Then let's go across, find my phosphate, highlight that column. And where they meet, I get an I. Now, the thing that I love about when students find I on the table is no one confuses I for a state of matter. They are forced to look at the key. I stands for nearly insoluble, which means it does not dissolve in water. So, if you have a copper penny and you throw it into a fountain, you know it's not going to dissolve. You can see all the other people who've made wishes in a fountain. So, if you throw a copper penny into a fountain, it's insoluble. It stays a solid. So these are our states of matter. KBr is dissolved or aqueous, and barium phosphate is a solid. That is your answer to the fourth question. And then your last question, number 5, asks, does a reaction take place? The answer is yes. We got at least one product that was a solid or a gas. In this case, our barium phosphate was a solid, so a reaction did take place. Anytime you get 2 aqueous products, it means that you started with 4 ions floating in water, and then you ended with 4 ions floating in water. That's not a chemical change. That's just making a mixture. So you need to get a solid or a gas as a product in order to have a reaction. Next, I gave everyone in class some time to work on this practice problem. And then we went over the answer together. So it's the same process. I want to find my aluminum. So I've got my periodic table and my common ion chart. So I'm going to start looking over here. No aluminum here. I'll start looking on the right side, and here's a quick hint. Since it's the first ion in my compound, I know it's not going to be a non-metal. It's got to be a metal. So it will be, maybe it's somewhere on this right side, but I don't need to look through any of these non-metals. Let's just look underneath my periodic table. And there it is, my aluminum. Now, most of these guys actually have more than one possible charge, which we can find by looking at the Roman numerals. There's no Roman numeral behind aluminum, so aluminum only has one possible charge. So if I look up at my group, I get a +3 charge. So aluminum is Al with a +3 charge. Then when I look for my nitrate, it ends with Ate. So that means it's one of my polyatomic ions. So if I look down this list, there it is. Nitrate is NO3 with a -1 charge. Next, I have sodium. So let me start looking over here, and there it is. Na, it's in group 1, so it has a +1 charge. And lastly, I have iodide. If it ends with "ide," it means it don't hide. So it's going to be somewhere on the front, one of these non-metals. There it is, iodine. And it's in group 17, so it has a -1 charge. Now that we have our 4 ions, we need to balance the formulas of our 2 reactants. So let me take my aluminum down first with my nitrate. My 3 from my aluminum is going to go down and become the new subscript for my nitrate. And the 1 from my nitrate tells me I only need 1 aluminum. So I'm going to just delete the charge on aluminum. And the 3 is going to go on my nitrate. But I need to make sure I go ahead and give it parentheses first because it's one of my polyatomic ions. Let me delete the charge and put this one as a subscript. There we go. So I have Al parentheses NO3 3. Now my sodium iodide. Let me copy my sodium and my iodide. I have a charge of 1 and a charge of 1. So subscripts of 1 and 1. I don't need to write anything. I just need to delete my charges. So now that I know my starting reactants, I can figure out my products. My suggestion, again, is start with your positive ions, start with your cations. So aluminum was the first ion in my first reactant. So aluminum is going to be my first ion in my first product. Sodium was my first ion in my second product. So now sodium is going to be my first ion in my second product. Now I've used half of my ions out of my 4. Let me place my anions. I've got my nitrate. I can't put nitrate with aluminum because that's where it started. So the only place I can put my nitrate is with my sodium. And then my iodide, well, now there's only one place where I can put any ions. That's with my aluminum. Now, it does not matter if you have your aluminum and iodide and then your sodium nitrate, or if you write it as your sodium nitrate and then your aluminum iodide. What does matter isn't the order of the formulas, but the order of the ions in the formulas. Anytime you write an ionic compound, make sure you make your positive ion the first one. I was looking at your double replacement lab, and there are quite a few that look like the right answer, but those negative and positive ions are switched. So now let's balance. The charge of 3 on my aluminum crisscrosses down to become the subscript on my iodide, and the 1 on my iodide becomes the subscript on my aluminum. So my aluminum iodide is Al(I3). Then my sodium and my nitrate each have a charge of 1. So I will need only 1 sodium. And I will need only 1 nitrate. So now I need to look these up on my chart. So let me find my aluminum right here at the top. And my iodide. And where these two meet, I get an S. So S stands for soluble. So soluble means that my state of matter is AQ. Next, let's look up my sodium nitrate. So I go down, I find sodium. And my nitrate. Where these meet, I get an S. So it's soluble. So its state is aqueous, AQ. So now, this is a bit unique. We haven't really had any problems like this yet. I have 2 dissolved products. So I have no reaction. I'm just going to go ahead and cross this out, and I'm going to type no reaction is my final answer for this. If I mix these 2 compounds, I will not get a reaction. I will get just those two compounds mixed together. If you don't get a solid or a gas, it means no reaction has taken place. The last question we had time to work on in class today was this one: zinc nitrate and potassium hydroxide. So, like all the others, we start the same way. Start looking up your ions on your periodic table and your common ion chart. Now, zinc is a little strange. Zinc is right here, right underneath the arrow that says it needs a Roman numeral, but it doesn't have one. And there isn't a charge on its group, so how do you figure out its charge? Well, if you go to your common ion chart, when in doubt, if you can't figure it out on the table, sometimes it's here on the chart. If you go all the way down on the left side, it's at the very bottom. Zinc is Zn with a +2 charge. Next is nitrate. It ends with ATE, so that means it's on your common ion chart. Scroll down that right side and you will find nitrate is NO3 with a -1 charge. Potassium, start looking at the chart again. I always like to start over here, and there it is. In group 1, potassium has a +1 charge. And then hydroxide is a kind of hard one to find. I always like to say if it ends with "ide," that means it don't hide. But hydroxide is my one exception to that rule. Hydroxide is our only polyatomic ion that we use that actually ends with "ide," so it's on our common ion chart, and its formula is OH with a -1 charge. Next, let's make our balanced formulas for our reactants. Let's take my zinc and my nitrate and do my crisscross rule. The 1 from my nitrate goes down to my zinc. The 2 from my zinc goes down to my nitrate. So I just need my 1 zinc. And then I'll need to put my nitrate in parentheses before I give it that 2. Oh, and I don't want the 2 up. I want the 2 as a subscript. There we go. So Zn, NO3, 2. And then my potassium with a +1. My hydroxide with a -1. Oh, well, 1 and 1, that's an easy balance. I just need to delete their charges. Now, let's figure out our potential products. Again, I always like to start with those first ions first. So zinc was the first ion in my first reactant, so now it's the first ion in my first product. And potassium was the first ion in my second reactant, so now it's the first ion in my second product. So now all I have are my 2 anions. And nitrate was with zinc, so now it's going to be with potassium. My hydroxide was with potassium, so now its only choices to be with zinc. So let me do my crisscross rule. We'll start with the easy one this time. 1 and 1. And then my zinc and my hydroxide. My 1 will go to my zinc, and my 2 will go to my hydroxide. Now be careful, a very common mistake is that students forget that hydroxide is a polyatomic ion. So that means if I have 2, I need to make sure I put it in parentheses. Okay, let's find out if this reaction takes place, if these 2 products are actually formed. Bring up my solubility chart. Find zinc at the very bottom. find hydroxide right there in the middle. And my zinc hydroxide is an I. So an I stands for nearly insoluble, so that will be a solid. So now we know that the reaction does take place. But just to be careful, let's check our potassium nitrate. You should only ever get one solid or gas product. So here's my potassium, and there's my nitrate. And where they meet, I get an S for soluble. So my potassium nitrate is aqueous. So my reaction does take place, and those are my two products. So that's all the practice we did in class today. Remember, your double replacement lab is due on your first class next week. If you're having trouble, or even if you're not having trouble, I highly recommend that you open up that optional practice worksheet. Even if you don't do that optional practice worksheet, I would copy and paste the framework that I gave you. You know, what are the 4 ions? What are your 2 reactants? What are your 2 products? And I would use that to help you answer your questions before you choose your answers in the actual lab. And remember, there are only 8 questions really. The first 8 questions are your reactions, and the second 8 questions are the videos of those same reactions. So make sure your answers are matching up. If you do choose to do those practice problems, please email me at my Gmail, mcpsmd.net, and I'll be more than happy to send you the PDF answer key to those practice problems. Practicing these types of problems is how you get a lot better. And make sure you watch the videos in the lab. I very clearly describe what's happening. So if you're not sure, was there a reaction? Wasn't there a reaction? I will tell you when there is and is not a solid precipitate. I hope to see everyone, cameras on, Monday and Tuesday, 1 week till spring break. Until I see you guys again, stay safe and make good choices, everyone.